Hello everyone and Assalamu alaikum. Welcome to my channel. I'm Ahmed and today we're going to learn how to choose the correct capacitor value for any single phase motors. So let's not wait anymore and start learning how to do this. So today we're going to learn how to calculate the capacitance value of any single phase motor. But before learning that, we need to know how to find out the efficiency of a motor. If you already know how to find out the efficiency of a motor, you can head on to the timestamp given below and you can start learning how to calculate the capacitance value. However, if you don't know, you need to know because the formula that is going to come for finding the capacitance value requires efficiency of a motor. Now, the formula that calculates efficiency of any circuit around the world is power out over power in times 100. And this formula here will give you a value in percentage. This percentage value will let you know how much does your circuit or your appliance draw and how much does it give. Depending on how much it takes and draws, this formula will allow you to know how much efficient this circuit is. Same way, we have efficiency of motors. Now, typically finding out efficiency of any circuit is piece of cake. It's very simple and easy. You just need the power in and power out. But for a motor, it takes a power in, but it doesn't give electrical power out. So we have to learn. It's very simple, probably less than a minute of learning how to find out the efficiency of a motor. Every single motor on earth, single phase motor or any motor, will have a horsepower rating, which is its mechanical capability rating. Okay, so how much it can mechanically run, that is compared to a horse, given the name horsepower. And 1 horsepower equals 746 watts of power. So now we have something that relates the mechanical world to the electric world. We know 1 horsepower, which is mechanically, will equal 746 watts, which is electrically. So when we have this relation, every single motor will have a labeled horsepower on them. So you can use this here, this known term here, to find out the required power output or given a power output. So let's say that we have a motor that is rated at 1/25th horsepower. Okay, we know that 1 horsepower equals to 746 watts. So 1/25th horsepower will equal 1/25th, and I'm going to erase this here, 1/25th times 746. Okay, you see the relationship? If 1 horsepower equals 746 watts, then 1/25th will equal 1/25th horsepower times 746. If you do that, you're going to get 1/25th times 746, and you get 29.84 watts. So a 1/25th horsepower, so let me write this down here, 1/25th horsepower will equal 29.84 watts of power. So this is mechanical and this is electrical. Now that we know how to find out the power output, okay, so you have the horsepower, and then if you have the horsepower, then you can find out the output power. Now what we need to find out is the power input, which is usually always labeled on the motor itself. Okay, let's keep this 29.84 in mind. So 29.84 watts. Okay, so keep that in mind. We know that is the power output, so you know how to find out the power output, so this one crosses out. We need the power input. It is usually labeled, if not power input, the power law, power equals to voltage times current. So you can measure how many amps your motor is drawing and at how many volts is it running. Then you can just multiply those two terms and you will get the power. It's just that simple. So let's assume that power in equals 90 watts and power out equals 29.8 watts. I can already see this is a very bad circuit. This is a very bad, inefficient motor. So power out is 29.8, 4 to be exact, over power in being 90 watts times 100 will equal, you, if you do this on your calculator, 33.1% efficiency. So this circuit is 33.1% efficient. So here you can see the difference of the ratio of how much it takes in over how much it takes out, and that's the percentage. In the percentage value you can see. Okay, so usually efficiency below 60% is considered as bad. 33% is very bad. So now you know that our main goal was to learn how to find out the efficiency of a motor. All you have to do is just take the horsepower value, multiply it with 746 watts, you will get the power output, and then you need the power input to apply this formula, right? You need the power input to apply this formula, and that's it. You can find out the efficiency of a motor. Now let's go and move on towards finding out the capacitance value required for a single phase motor. This was very important. You're going to see this is very important for finding out, because efficiency is required in finding out the capacitance value. Okay, let's take a look at the formula required to find out the capacitance of a single phase motor. The formula is this. We need the power input value. Okay, so we need the power input value. We need the efficiency of your motor. And then we need the voltage input squared. Don't forget this square here. Okay, there is a square here. Don't forget the square. And then we also need the frequency at which this motor is running. Then we can find out the capacitance value in microfarads. Okay, so let's take a example circuit, example motor, and then we will find out the value. Here I have given the required values, and let me write down the formula. So all we need to do is just plug these values into this formula here. So we know the power input is 70 watts, the efficiency is 50%, and I don't need to explain how to find out efficiency, we just found it out. So efficiency is 50% times 1000 over voltage squared. Voltage input is 220 volts AC. So we write 220 squared times frequency for F, which stands 60 Hertz in our case. Now let's find out the capacitance value required in microfarads. 1.2 microfarads. So you need a capacitor that is of 1.2 microfarads, or you can plug in a 1.5 microfarads, which is still okay. So as you saw, this formula is very simple. All you need is the power input, the efficiency, and if the efficiency is labeled, then it's your lucky day. You just put the efficiency. You need the power input, the efficiency, the input voltage, and the frequency, and you can find out the required capacitance value. So also you know now how to find out the efficiency of a single phase motor. All you have to do is just use the formula power out over power in. The hard part is to find out the power out, which is still easy. All you have to do is just get the horsepower and then multiply it with 746. It's going to give you the power output in watts, and then multiply this by 100 to get it in percentage. And with that said, now you know how to find out the efficiency of a single phase motor, also how to find out the capacitance required for any single phase motor. So if you enjoyed watching my video, don't forget to like, share, and subscribe, and I will see you in the next video.